Today we are starting a new test series in order to cover the third unit, that is waves and oscillations. So this series, that is S1 series, will cover waves and oscillations plus optics. So today it is the first test regarding this series, right? So here we will be covering theoretical part of simple harmonic motion, meaning mostly it is based on equations, and there will be a second part of this simple harmonic motion, that is to cover the applications of simple harmonic motion, right? So by participating in this test, you will have a solid understanding of theoretical part of the simple harmonic motion, right? Okay, we'll move to the first question. Consider the sentences below. All periodic motions are simple harmonic, right? So you have to clearly understand the difference between a periodic motion, just a periodic motion, and a simple harmonic motion, right? So first you have to understand that. Periodic motion means within a considered period, if the same within like consequent consecutive periods, if the same motion happens, it is called a periodic motion, right? For an example, if the earth rotates around sun every 365 days, that is a periodic motion, right? uh, so if you drop a ball and it drops down and comes up, let's say without energy loss, then within the same period it does the same motion, right? Same motion. So those are called periodic motions. But the thing is, all those motions are not simple harmonic motions. There are special requirements for something to be simple harmonic. Like every simple harmonic motion happens within a certain time, within a certain time period, the same motion, right? Same motion. But there are special requirements in order for that to be simple harmonic. So the earth rotating around the sun is not simple harmonic, right? Because it is in a circular motion. Simple harmonic motion occurs within a linear path always. So it is like this, in a linear path. It cannot be like this, right? Cannot be in a circular path. It is in a linear path. The other requirement is the unbalanced on the force that causing the simple harmonic motion. We call that driving force, is always towards the center, right? So if the object is at this side, it is towards the center. If it is at this side, again it is towards the center, right? So that is another requirement. And the acceleration of simple harmonic motion is proportional to the displacement from the center. So if a periodic motion obeys these as well, only then we call that simple harmonic motion. So the first one is not correct, right? All periodic motions are not simple harmonic. But all the simple harmonic motion are periodic, right? B is correct. Time period is proportional to square of the amplitude. It is not true, right? Time period is not proportional to square of the amplitude. So you will understand when we are talking about energy of a simple harmonic motion, particle in a simple harmonic motion, the energy of that particle is proportional to the amplitude squared. But it is not time, right? It is energy that is proportional to the amplitude squared, not time period, right? So only B is correct, okay? Only B is correct, right? Second question. A mass in simple harmonic motion around a point O with amplitude A and time period of capital T. Displacement of the mass when it moves for 3t over 4 after passing the point O is, right? So let's say this is the center, that is O, So simple harmonic motion occurs like this, right? Goes to this side, comes back to the center, goes to this side, and comes back to the center. So amplitude is what we call the maximum displacement from the center. So here it is A, and the other side also has the same amplitude, right? Right. So time period is, they say it is capital T. Time period means this. In order to complete the one cycle from here to here to here. So that time is what we call time period. So you have to clearly understand what time period is, right? So you know that from here to here, it is a 1/4 of the motion, 1/4 of the cycle. So the time period here should be T04. I mean, not time period, time should be T04. If T is 0 here, here it is T04. Then here another 1/4 of the cycle. So again, you need to add T04. T04 plus T04, it is T/2. Here time is T/2. Then another 1/4. So it should be 3 times T/4. T/4, T/4, T/4. 3 T/4. Then comes back. When it comes back, then the complete time period. 4 times T/4s. So it is a one time period. Now it has completed the cycle. It has completed the cycle, right? Okay, so in the question what they ask is displacement when time is 3T/4. So 3T/4 means here. So you can see displacement is what? Now the object is here, right? So displacement is this much. That is amplitude, right? So the answer should be capital A. So it should be fifth one. Third question. A particle in simple harmonic motion, 0 point takes to move from center to its first amplitude. Frequency of the particle is, right? So this is what they say. So let's say the particle is here at the center, and first amplitude means here. So this takes, they say it is 0.5 seconds, right? So you know that this is 1/4 of the whole cycle, right? So it goes here, comes here. So this is, if the time period is capital T, this is 1/4 of the time period. So this is T/4, right? So what they ask is capital T, right? So now you just have to find capital T. So capital T is equal 4 times 0.5. So it is 2, right? T equals 2 seconds. So what they ask is frequency. So frequency, you know, that is equal to 1 over time period. 1 over time period. You're supposed to know these equations, right? So 1 over time period is 1 over 2. 1 over 2 means 0.5 hertz. Got it? So the frequency is 0.5 hertz. So meaning of that, per second, it does a 0.5 of the cycle. That is what it means, right? Within a second, it does a 0.5. That is what frequency means, right? How many cycles per second? When you're talking about frequency under simple harmonic motion. Fourth question. A small object in simple harmonic motion around point O. Its amplitude is simple A. Time period is capital T. So amplitude means from here to here it is simple A, and the time period is capital T in order to complete one cycle. Okay. Displacement of the particle after T/8 starting from center is, right. So you know that here it is from here to here it is T/4. Okay. From here to here it is T/8. So it should be half of T/4, right? T/8 means. So what they ask is the displacement, this displacement, when the time is T/8, 1/8 of the time period, what they're asking is displacement of the particle. So there's a clear, there's a something you need to clearly understand. When this is half of the time, right? T over 8 means half of this much. The answer does not become A over 2, right? If the time is halved, the displacement does not become half. The reason is this motion is not uniform, right? You know, in simple harmonic motion, nothing is constant. Displacement changes, velocity changes, and the acceleration also changes at every moment, right? So you cannot say if the time is half of that, displacement also should be half of that. You cannot say that. You have to clearly understand that, right? You know, the average displacement from here to here is higher compared to the average displacement from here to here, because at this region the average speed of is higher, but when it comes to here average speed is lower, right? Because at the center we have the maximum speed, and at the amplitude we have the zero speed is zero there, right? So between maximum and zero speed changes from here to here, right? So within this time period t over 8 it moves a larger distance. So in order to calculate that distance, you know, you cannot apply linear motion equations. Those equations are applicable only for constant acceleration, right? So none of those equations can be applied in a question like this. So there we have a set of new equations designed for simple harmonic motion. You have learned them under theories, right? So this equation, x equals amplitude times sine theta, this equation, this one, this is the equation we use to find the displacement. For further explain this, I'll just say sine theta plus psi. If there's an initial phase angle, we just have to use this one. But in this case, we don't have an initial phase angle. The motion starts when t equals 0. The motion starts from the center. So this does not have an initial phase angle. So we don't have to use this equation. I'm revising you the theories as well, right? Okay, so we can use this one, right? So x equals, amplitude is, there's a simple a, sine. Instead of this theta, we can use omega t, right? Omega t. So you know that in a simple harmonic motion, omega is constant, right? Angular, it is not actual angular velocity, it is regarding the simple harmonic motion, but you can consider the related circular motion for that simple harmonic motion. In order for that to be simple harmonic, this omega needs to be constant, right? So if it is constant, you can apply theta equals omega t. Okay, so instead of theta, just put omega t. So a sine. So how do we find omega? This equation, omega is equals to 2 phi capital T. 2 phi means the complete cycle, 360. You must substitute in pi, right? I mean radians. Divide by the time it takes to complete the cycle, that is time period. So you have this equation, 2 pi over T. There's another equation, by 1 over T. Instead of 1 over T, you can put frequency as well. So you need to know these equations as well, right? You have learned this in circular and rotational motions. So you can apply these ones for constant angular velocities, right? Here it is angular frequency actually, right? So instead of omega, I can apply 2 pi divided by capital T. Then the time they say is t over 8, right? So that is what you need to find, t over 8. So a sine dt cancels off 4 pi over 4, sine pi over 4. Pi over 4 means 45 degrees, okay? Pi over 4 means 45 degrees. So sine 45 means 1 over root 2, right? So it is 1 over a over root 2. So this is the displacement, a over root 2. That is the displacement of the simple harmonic motion when t over 8. So you can see it is not a over 2, right? Right? It is not a over 2. It is more than a over 2. Right. The fifth question. Displacement of a particle in simple harmonic motion is given by this equation. Time period of the particle is. So they have given an equation y equals 5 sine 0.2 pi t minus 0.5 pi, right? So what they ask is time period of that particle, right? So this describes the motion of the particle, but what they asking is time period, right? Okay, so this is the full equation when it comes to simple harmonic motion. So omega t plus initial phase angle. Okay, they are only asking about time period. So the time period is involved with omega. So you can see in front of simple t, the everything should be omega, right? In front of simple t, everything should be omega, right? So using this one, you can find the time period. If there's amplitude, amplitude should be 5. If there's initial phase angle, it should be 0.5 pi, right? But here they ask only about time period. So we can say omega is equal to 2 pi divided by capital T, right? So pi cancels off to 0.1, right? So 1 over t is equal to 0.1. So take it the reciprocal of both sides. So t is equal to 1 over 0.1, which is 10, right? So the time period for this motion is 10 seconds. Got it? It is 10 seconds. Right, sixth question. An object in simple harmonic motion passes its center with speed v. If its amplitude is doubled, speed of it passes the center is, right? So the speed uh, uh, it passes the center means the maximum speed, right? So I'll just briefly explain about speed as well, right? Just to recall about speed. So in the previous questions we discussed about displacement. Now I'll just explain about speed or the velocity of simple harmonic motion, right? So you know that the ends speed is 0. You know, it is at instantly at rest, right? It has to turn back. So at this point it is instantly at rest. Two ends it is at rest instantly. And then accelerate. So the maximum speed should be at the center. Speed is maximum at the center, right? When it goes here and when it comes here. So Vmax, then speed decreases to 0, then increases to Vmax, then decreases to 0, then increases to Vmax. So to get the speed or the velocity, we have this equation. Omega a squared minus x squared. You need to remember this equation, right? Right? So from this equation, you can see when the displacement is 0, we have the maximum speed. A squared minus 0. So for maximum speed, it is a V max, right? We have a squared root, that is omega a. This equation also you need to remember. Maximum speed or the velocity is equal to omega a, right? So here what they say is the amplitude is doubled, right? Amplitude is doubled. The new maximum speed is, even though they don't say maximum speed, you need to know when it is at the center, it has a maximum speed, right? So if this is doubled, omega is constant, V also should be doubled, right? So the answer should be 2V. This is constant, and if amplitude doubles, maximum speed also has to doubles, right? So if it is initially V, now it is 2V, right? It is 2V. For an example, if you have a simple pendulum and if you, let's say, you move that 1 centimeter to this side and release it, the amplitude is going to be 1 centimeter. And if you move 2 centimeters from the equilibrium, now the amplitude is twice. Now the amplitude is going to be 2 centimeters, right? Then the maximum speed that is at the center also doubles, right? Okay, we'll talk about simple pendulums at the second part of this test, right? Seventh question. An object in front of a linear scale is in simple harmonic motion around 10 centimeter and 5 centimeter to 50 centimeter. Incorrect sentence is, right? So it is a linear scale. So here they have, we have 5 centimeters, 10 centimeters and 15 centimeters, right? This is part of the linear scale. Around 10 centimeters. So it is, center is 10 centimeter mark. So it is doing simple harmonic motion like this, right? Okay. Right. So what they're asking is incorrect sentence. If you think about first one, object has a maximum speed at 10 centimeters. So at 10 centimeters, it is the center, right? So at the center, we know it is the maximum speed. So one is correct. Second one, time to move from 10 to 11 centimeter is higher than time to move from 14 to 15 centimeter. So 10 to 11 centimeter means from here to here, let's say. From 14 to 15. So time to move from 10 to 11 is higher than the time to move from 14 to 15. Right? You know that average speed closer to the center. So what they are asking is within this time and within this time. Right? So you know that average speed within this region is higher. Closer to the center, it has more higher average speed, right? You know that at the near the center, it has more higher average speed compared to the ends, right? So within this region, it has higher average speed. So the time is low. Time is low. But it says higher, right? 10 to the 11 is higher. So incorrect one is second one. Right? So that's the answer. Second one is the answer there. You don't even have to check the rest. If you want, you can check that, right? So, but in the exam, if you get the answer, in order to save the time, if you get the correct answer, there it is not required to check the remaining answers, right? But if you only have the time, after doing all the other questions, if you only then have the time, you can make sure In order to make sure that you got the answer, you can check the remaining. Otherwise, you don't have to, right? Because the time is really critical. Right. Eighth question. Particle in simple harmonic motion has a speed 5 centimeter when displacement is 12 centimeters. When displacement is 5 centimeter, velocity is 12 centimeters per second. Amplitude in uh, centimeters is. So they're asking about displacement, amplitude, and velocity. So you need to get the relevant equation. So you can see, so this equation has amplitude and displacement and speed. Okay. So you have to use this equation. So you have to compare two cases here, right? When the speed is 5, you just have to substitute. Speed is 5. They say displacement is 12. Okay. Then when displacement is 5, displacement is 5, speed is 12, right? So you can have two equations. So these are two simultaneous equations. So by solving that, you can find capital A. So what they ask is amplitude. If you want, you can find omega as well, but they are not asking about omega, they are asking about amplitude. Right. So simply you just have to get rid of omega, right? So you can simply divide the equations. So if you divide 1 by 2, omega cancels off. A squared minus 144 divided by a squared minus 25. Root is still there. Then square both sides. So you get 25 divided by 144. A squared minus 44, a squared minus 25, right? So you have to be smart about when you are doing this simplification, right? Right. You need to save time as well, right? Don't overcomplicate the simplification. Always look for a method to go for the answer simply, right? Okay. So cross multiply 25 a squared minus 25 equals to this side 144 a squared minus 144, right? So take out the brackets. 25 a squared minus 25 times 25. I'm not going to write 625, right? Just 25 times 25. Just as much as possible, just avoid simplifications. Okay. Try to cancel stuff out. Okay. Here you have 144 a squared minus 144 times 144, right? Unless it is extremely necessary, don't do unnecessary calculations. Okay, it wastes your time and overcomplicate the simplification, right? Now I'll just put 25 to the other side. So it is 144 minus 25, 9, 13, 11, right? So 119 a squared. Take this to the other side. So we have 144, it is squared actually, minus 25 squared. Okay. Now we have difference of 2 squares. Difference of 2 squares. So how can you write this? This is like a squared minus b squared, right? So it is a minus b, a plus b. You can write it like that. So here it is 144 minus 25. 144 plus 25 equals 119 a squared. Right. Here you can see if you add these two, 144 plus 25, No, sorry. If you subtract this 144 minus 25, what do you get? 119. Do we get 119? Yeah, 119. So this is 119, then you can cancel that, right? If you just, without considering this, if you just multiply this and all that, then the calculation is going to be really complicated, right? Right. Then you have 144 plus 25, that is 169 equals a squared, right? So a, take the root of both sides, 169 root. So that is going to be 13. So the unit should be centimeters, right? We didn't do any conversions. So the amplitude is 13 centimeters, right? Right. Ninth question. Amplitude of an object is simple is 4 meters. If the maximum acceleration is 0.2, so amplitude is 4 meters, right? Maximum acceleration, A max, is 0.2 meters per square second. Acceleration when the displacement, so A max is given, what they ask is acceleration when the displacement is 3 meters. When displacement is 3 meters, what they ask is acceleration. Not the maximum, right? It is acceleration. So here you have to consider the equation to find the acceleration, right? So this is the equation. I'm not going to derive this, right? Acceleration is equal minus omega squared x. So unless you have to draw a graph, you don't have to use negative sign, right? For these questions, you don't have to consider the negative sign. You just have to find the magnitude, right? So A is omega squared x. If you want, you can write the negative sign in the equation, but then neglect it, right? Because you only need to find the magnitude there. You already know the direction, okay? Right. So you can see we are given a max, maximum acceleration. So you know that when x changes, simple x changes, a changes. Omega always a constant for simple harmonic motion. So you can see a max is equal to omega squared x max. X max means maximum amount of displacement is amplitude, right? So for maximum acceleration, you have this equation. You need to remember that as well, right? You must remember this one, but if you remember this one, you can easily remember this. So if x becomes capital A, then it is going to be the maximum acceleration, right? Right. So they have given a maximum acceleration and amplitude. So I can simply substitute it here and find omega squared. So A max is 0.2, omega squared, amplitude is 4. So omega squared 0.2 divided by 4. So I'll just divide by 2 both, 0.1, 2. So if you divide 0.1 by 2, you get 0.05. So this is omega squared. So now you found omega squared, 0.05, right? So what they ask is acceleration when displacement is 3 meters. Okay, for that one, you just use this equation. So omega squared, you already know that is 0.05. X is 3 meters. So it is 0.15 meters per square second. 0.15 meters per square second, right? So the maximum speed is acceleration is 0.2. Now acceleration when displacement 3 meters is 0.15 meters per square second. Okay. Uh, I'll further explain about acceleration. You know that. So for the simple harmonic motion, we have velocity at the ends is 0. And we have the maximum velocity at the center, right? It is opposite when it comes to acceleration. Here acceleration is max. When the velocity is 0, maximum acceleration. Here as well maximum acceleration, and here acceleration is 0. So it is at the center. Acceleration is 0, right? Right. 10th question. Graphs below show the variation of displacement and acceleration with time. Value of time period in seconds is, okay, so they're asking about time period, right? So time period here, this one. Here also time period capital T. They have given the variation of displacement and acceleration against time graphs, right? So you know that these graphs are either sinusoidal or it could be a cosine graphs, right? So when it comes to x and acceleration, for x and acceleration, you know it is the sine functions graphs. For velocity, is a cosine graph. You need to learn those in theories, right? Right. So here, but here for this question, you don't have to consider those. You need to be able to like grab details from those graphs. So according to the graphs, the data given are these 2, 2 and -8 and 18, right? So what are those? You can say this 2 is the maximum displacement, right? So it is amplitude, okay? So the amplitude is 2 meters. That we know from the graph. Here we have given the acceleration. This should be the maximum acceleration because it is simply the maximum value of the graph, right? It goes to the 18. It doesn't go beyond that. So the maximum value of acceleration is 18. So we know A max, that is 18 meters per square second. So from these two, we can find the time period. So what's the equation for maximum acceleration? A omega squared, right? So maximum acceleration is 18, amplitude 2, omega squared. So 18 divided by 2, that is 9. Omega squared is 9. So omega is 3. Okay. But what they ask is time period. You know that omega is equal to 2 pi divided by time period. Okay. 2 pi divided by time period. Then you can cross multiply this. T goes here, 3 comes here. So it is 2 pi divided by 3 seconds. Right? T goes here, 3 comes here. 2 pi divided by 3 seconds. That is the time period. So here the answer sign pi. If you further need to simplify this, you can substitute instead of pi either 3.14 or 22/7. If you want to go for a number, right? Numerical value. Right. 11th question. Man weighing 50 kilogram is sitting on a weight scale. If the weight scale is in simple harmonic motion horizontally with amplitude 0.05 meter and frequency 2 Hz, maximum and minimum readings of the scale is. So it's like a platform like this. Let's say on a platform, there you have the weighing scale and the man is sitting on it, right? So this one oscillates back and forth in a simple harmonic motion. And they say amplitude is 0.05 meters, and also given the frequency as 2 hertz, right? Here what they ask is maximum and minimum readings of the scale, right? So reading of the scale is equal to the normal reaction force acting on the man, right? You need to remember that pressure balance. Whenever they are asking about reading, you just have to find this normal reaction, right? I'm not going to explain the theories. R here, and another force on the man is his weight, mg, right? So you can see when it oscillates like this reading increases, decreases, and it changes, right? So as it is moving, so let's say this is the center. If it is moving upwards from the center, so acceleration is towards the center. If it is below the center, acceleration is upwards, right? Let's say platform is at this level below the center. Now the acceleration is upwards, right? Thinking that you can apply F equals ma for that instant. So the normal reaction, that is R, weight is mg, equals ma. Then R is equal to mg plus ma, right? Mg plus m, instead of acceleration, you can write what? So this is simple harmonic motion, right? Omega squared x. Instead of acceleration, that is omega squared x. So from this equation, you can see this term is a constant, right? Mg does not change, but this, as it is in simple harmonic motion, this x changes, simple x changes, right? This x could be capital A, or it could be simple a. Sorry, negative. This x can be plus a or minus a, right? So from this equation, you can see R max equals should be what? Maximum value of R. Mg does not change. M omega also does not change. X maximum, when it is X maximum, it should be R max, right? Then R min should be what? Mg. If you need to substitute the minimum value of A. Minimum value of A is minus A, right? So it is Mg, so it's going to be Mg minus M omega squared A. Correct? So R max equals, if you want, you can take M out. Anyway, simple M, they say it is 50 kilogram. And M is 50 kilogram, right? First, I'll just find this. This is maximum acceleration. Can you see that? Omega squared A is maximum acceleration, right? So I'll just find maximum acceleration separately. Omega squared A equals, omega means 2 pi f, right? 2 pi f is omega times capital A. 2 pi, frequency is given as 2 hertz. Amplitude is 0.05. So here you have 4 pi squared. So 4 pi squared means 4 squared means 16, pi squared 0.05. So in these questions, they have rounded off the values. So here you can consider this 5 squared to be 10, right? So you have 16, 10, 0.05. 10 times 0.05 is 0.5. Multiply 16, then you get 8. Okay, so this is the maximum acceleration, that is 8 meters per square second, right? Then you can simply add that here. So here mass is 50, 50 times 10, that is 500, plus here you have 50 times omega squared is 8. So 50 times 8, it is 4400. 400 plus 500, that is 900. Right? So the maximum reading is 900 Newton. Right? Here, mg means 500. Here also same value, right? It is 400. So it's going to be 100 Newton. Got it? So the reading of this scale varies between 900 and 100. Right? So at the bottom, at here, at the minus A, acceleration is upwards. So there we have 900 Newton. Then at the top, we have 100 Newton. So the value varies between 900 and 100, right? Right, 900 and 100. And at the center, the value is 500 kilogram, right? At the center, acceleration is 0. So the value is 500. So you can see it changes between 100, 500, then 900. Again, 500, 100. Likewise, it keeps changing, right? Right, 12th question. So after this one, the questions are based on energy, right? Energy of simple harmonic motion, right? A mass 0.5 kilogram is in simple harmonic motion. Its total mechanical energy is 0.04 joules. Display. And its time period is pi. Pi seconds is the time period. Amplitude is, so what they ask is amplitude, right? Right. So, time period is given. They are asking about amplitude, right? Amplitude. And the total energy also is given. So, we know that total energy of simple harmonic motion is equal to kinetic energy plus potential energy, right? So, when the kinetic energy is maximum, meaning when it is at the center, potential energy is 0, right? When K is max, potential energy is 0. Then at that case, total energy is completely equal to Ke max. Okay. Then at the end, at the amplitude, it has the maximum potential energy. You know that when it is at the maximum potential energy, its velocity is 0. So the kinetic energy is 0. So Pe max also is equal to Te, right? So by using Ke max or Pe max, you can find the total energy. You can derive an expression for Te, total energy. Okay, using this one, I'll derive that. So we know that total energy is equal to Ke max, right? Ke max means kinetic energy at the center. So what's the equation? Half m v max squared. So we have half m. V max means a omega, right? A omega, that is V max. So here we have half m a squared omega squared, right? Now you have an equation for total energy. If you can remember this, it's better. But if you don't, you just have to derive that in order to find the total energy. There's another important thing I have to pinpoint here. Earlier I discussed that total energy is proportional to amplitude squared, right? So from this equation, it is obvious. Mass does not change, omega constant. Total energy is proportional to amplitude squared, right? So from this one, you can get that. Okay. Right. So higher the amplitude of a SHM, higher the it is squared of that, the total energy, right? If amplitude doubles, total energy quadrupled, right? Okay. So given this data, we can find amplitude. I think mass as well is given, right? Mass 0.5. Mass is 0.5 of the object, right? So total energy is 0.04, half mass is 0.5, time period is given, right? Instead of let's say a squared, instead of omega, you can write 2 pi divided by capital T. That is omega squared, right? Okay. Then if you want, you can do a simplification here. So this is also 1 over 2, right? 0.5 means 1 over 2. So 1 over 2, it becomes 1 over 4. Get to the other side. 1 over 4, then it multiplies by 4. So this becomes 0.16 equals a squared 2 pi. Instead of capital T, you can use pi. Okay. Then if you want, take the root of the whole thing. There are other ways you can do any methods of simplification. Okay. So take the root. 0.16 means 16 over 100. When you take the root, it becomes 4 over 10. So it is 0.4. A times 2. I took the root of the whole thing. Right? Then A is equal to what? Divide by 2, 0.2 meters. Right? 0.2 meters, that is the amplitude of this simple harmonic motion. Right? That is the amplitude. So here you have to understand this when it comes to energy. That is all you have to understand, right? Maximum, when it is maximum, it is equal to total energy. When potential energy maximum, it is also total energy. Then you can quickly derive this. You can quickly derive it. Once you understand this, you can get the answer, get this equation quickly, right? You don't have to memorize this. Once you understand that, you will quickly write this one. You don't have to write any of these. This is just to explain the theory, right? Because I have to explain the theory a little bit. Right. 13th question. An object in simple harmonic motion has an amplitude capital A. Displacement of the object when the kinetic energy is equal to potential energy. Okay. When the kinetic energy is equal to potential energy. So this is the requirement, right? Kinetic energy equals potential energy. So when this happens, what they ask is displacement, x. So we know this equation. Total energy is equal to kinetic energy plus potential energy. Right? Here, if you want, we can write like this. Instead of potential energy, I can use this kinetic energy for this question, right? Because that is what they ask. So 2ke is equal to total energy. Earlier, I derived that total energy is equal to what? Half m v squared. Actually, it is v max squared, right? So v max is a omega. A omega is squared. So instead of total energy, you can get this one. Substitute it. Half m a squared omega squared equals 2 ke. So here what they ask is displacement, right? Simple x. So instead of kinetic energy, I can use this half mv squared. Okay. If you want, you can get rid of simple m and this 2. So here we have a squared omega squared divided by 2 equals v squared. Instead of this v, you have to write that in terms of a, omega and x, right, in order to get the answer. So we know that this equation v is equal to omega a squared minus x squared. You need to have a great memory of this equation, right? Once you recall, you should be able to like imagine that equation, right? That comes with practice. Okay. So a squared omega squared divided by 2 equals v squared. So v squared, you can see you need to get the square of this. So here you have omega squared, then you have a squared minus x squared. Okay. Then omega squared cancels off. You have a squared over 2 equals a squared minus x squared. Take x to this side and a squared over 2 to the other side. So x squared is equal to a squared minus a squared over 2. So what do you get? 2a minus 1. So you get a squared divided by 2. That is equal to x squared. Then x is equal to, take the root from both sides, a divided by root 2. Okay. So when the displacement is a divided by root 2, you get half of the kinetic energy and potential energy equal, right? Meaning if the total energy is 1 joule, so when x is equal to a over root 2, you get 0.5 joule of kinetic energy and 0.5 joule of potential energy, right? You can do this in any way you want, right? Like you can do the simplification any way you want, but to do that you have to understand, you have to clearly understand the concept, energy behind simple harmonic motion, right? So that comes with practice. Okay. Right. 14th question. 4 kilogram of mass in simple harmonic motion has a variation of potential energy with displacement as shown below. Time period. In this case, they are asking about time period, right? And they say this is the variation of potential energy, right? And from this you can see this amplitude is 0.2 meters. So you have to extract those details from the graph. So amplitude is 0.2 meters. And also maximum energy, maximum potential energy. You can see it is 1 joule, right? So earlier I proved that total energy is equal to maximum potential energy, and also this it is also equal to maximum kinetic energy as well, right? So the question what they ask is capital T. There are many ways you can do this, right? But I will say Ke max, I will use this one. Ke max equal 1 joule. So what is Ke max? Half m. V max is squared. V max is A omega squared equals 1. Right. So half, mass is 4, amplitude is 0.2, right? And omega, because you need to find time period, I write omega in terms of 2 pi divided by capital T. And is squared equals 1. Then just do a simplification in order to find time period, capital T. 1, 2. So you can, if you want, you can see 0.2 as 1 over 5. Then multiply 2 pi divided by 5. Then it gets squared. 4 pi squared divided by 25 capital T equals 1. Uh, T squared, right? So T squared goes to this side. So here you have 8 pi squared divided by 25 equals T squared. Then take the root. So you have 2 root 2. When you take root of 8, pi divided by 25 root means 5 seconds. 2 root 2 pi divided by 5 seconds. Do we have an answer there? So if you don't understand something, you can recheck the explanation, right, on that question. So then you will probably will get the that understanding, right? The most important thing is you need to do these questions first. That's why I'm giving you the test, right? After that you can check the explanation. Okay, you have to do these questions on your own. That is the most important part there, right? Because in the exam you are facing new questions on your own. Okay, right. 15th question, graph that shows the variation of potential energy of a particle in simple harmonic motion with time is, right? So you know they are talking about energy. So energy cannot be negative, right? Especially when it comes to simple harmonic motion. uh, so negative, any graphs that has negative values you can get rid of. First one and fifth one you can get rid of that. It is not constant, right? Potential energy is not constant. Third one you can get rid of, and also it is not linear like. So fourth one also you can get rid of. So the answer should be second one. So simply you can get the answer like that. The another thing is it should be kind of like sinusoidal, right? So from that also you can think the answer should be second one. To get the exact graph, I have given you that explanation in the mark scheme, right? So you can check that mark scheme. So simply you can derive an expression for potential energy, right? It is not that complicated. You can, if you don't understand, you can check that mark scheme, right? Then you can derive that. Okay, so the answer there should be the second one.